All right, well, now we're going to look and talk about the distance from a point to a line. And the shortest distance from a line to a point that is not on the line, the shortest distance would be that point would be perpendicular to the line. And if we're doing this on paper somewhere, you're really going to need a compass and a ruler and those kind of things. And you can get some really accurate representations of what's going on. But I'm going to use GeoGebra here in a minute. We're going to play around a little bit and look at some things. It says, construct and name the segment that represents the distance from Q to PR. And of course, we want that shortest distance. And again, I can't really hardly do it, but if I were to do that, I would have this point Q, and I would draw a line perpendicular that would intersect with PR, and that would represent the shortest distance. In fact, you can look, if I went out like this, or if I went out like that, none of those lines look like that would be the shortest distance. But let's go to GeoGebra, and we'll play around a little bit and have some fun with it. All right, I've drawn an object in GeoGebra that was pretty close to what we saw on that previous slide where I got points Q, P, Q, and R. And in fact, if you look over here on the left, you can see the coordinates I used for Q and P and R. And it even gives me the distance of the segment. So segment F, which runs from P to Q, is 4.47 units, whatever that is. And the segment QR, with endpoints of Q and R, has a distance of 6. And the segment RP or PR, whichever one you do it, has a distance of 8.94. But let's say I wanted to draw a line perpendicular to Q from Q to a point on line PR. Well, in this, I could go this tool right here, and I can choose this perpendicular tool, and I can click on Q, and I can click on the line somewhere, and it's going to pop that line in perpendicular to Q. And you can see that it even gives me an equation for that line, which would be y equals positive 2x minus 8 once I rearranged it. Now let's put a point right here at this point of intersection. Right there, it says it's point A. All right, now what if, just for fun, let's see if I can get the distance of that. Let me put this into a segment. So I'm going to click on Q and A. So it'll give me a distance reading. And if you notice right here over on the left, the distance between point Q and A is 2.68 units. Well, what if I put another couple of points on this line? I'm going to put one right here, and I'm going to put one right here. And I'm going to draw segments between point Q and B and Q and C. We're going to compare that distance. We already know between Q and A is 2.68. So let's see, did I choose segment? No, let's do segment. All right, so between Q and B, how long is that? 3.28. And between, that's compared to, what do we say, 2.68 between Q and A. And that's perpendicular. Remember, I used the perpendicular tool. And then we go Q and C, and the distance of that is 4.63. And so certainly of those 3 points we chose, the one that is the shortest distance is the one that was perpendicular from point Q to, and perpendicular to, passing through perpendicular to PR. That's the shortest distance. So the shortest distance between a point and a point that's not on the line to a point that is on the line is perpendicular from that point to the line. Shazam.